Jai Hind and pleasant good morning. Myself, Nitisha, representing TSWR AFPDCW, here on to speak about deadlock handlings and prevention. Before going to deadlock handlings and prevention, let me give an introduction of a deadlock and what is a deadlock and how it occurs. Deadlock. When two or more processes are waiting or happening of some event, but the event does not happen, that is called deadlock. Let me give an example. I wanted to take an account in a bank. Then bank account says there are some conditions. In order to make an account, we need to deposit some money to open a bank account. Then I start arguing to the bank accountant that first I'll take an account, then I'll deposit some money. So the bank accountant and myself both are arguing each other. No one wanted to compromise. So there are two processes happening, but the main event is not happening. This is nothing but deadlock situation. Let me give the other example also. Here R1 resources is being accessed by the P1 process. P1 again requesting to the R2. R2 is already accessed by the P2 process. P1 again requesting to the R1 process. Here the process requesting, accessing going on. No one wanted to compromise. So this is such a kind of deadlock situation. Now there is also variation methods to handle a deadlock. And before going to these variation methods, let me explain you there are some necessary conditions of the deadlock. There are four necessary conditions of a deadlock. The four conditions are mutual exclusion, no preemption, hold and wait, and circular condition. First one, mutual exclusion. Mutual exclusion means non-shareable. We need to make mutual exclusion as a false statement. How and why we need to make mutual exclusion as a false statement? Simple. In order to prevent the deadlock, there are two conditions. We need to make these four conditions as a false, or at least one among these four statements as a false. Then we can prevent the deadlock. That's why we are making mutual exclusion as the false one. It means that non-shareable, if you make shareable, then we can make mutual exclusion as a false one. Then we need to share. Let me give an example. R1 resources has been shared by the P1 process, P2 process and P3 process. It has been shared, so then mutual exclusive become false. But there is a bit more condition, is printer. Printer is a non-shareable. In such type of conditions, we can't make mutual exclusion as a shareable or false statement. Next one, no preemption. No preemption means, no preemption false means preemption is true. We need to make preemption true. How we can make preemption as a true? By using time quantum method. Then what is this time quantum method? This time quantum method is T1 is allocating T1 time to access the R1 resource. At the same time, T2 allocating time T2 to access the R1 resources. Then P1 is allocating time T1 to the R1. When this allocating time is completed, P1 should release the R1. It should not access R1. It should release the R1 so that P2 can use the R1 resources. This is nothing but preemption method. Time quantum theory depends on time quantum theory. Next, hold and wait. Hold and wait name itself says that try to not hold and wait, then deadlock can be prevented. See, this is a process. I am giving many resources to this process. This process will accept at most one resources. It means that here we are avoiding hold and wait situation. So this will be the best example for the hold and wait. Next, last one, circular wait condition. Circular wait condition. How can we make circular wait condition as a false? Simply by giving a numbering. Like giving a numbering to the resources CPU 1, printer 2, scanner 3. Let me give an example. See, 1 is accessed by the process P1. P1 is requesting to the third resource. Third resource is already accessed by the process P2. Then give me an answer. P2 can access the 1? No, because here we have a condition in a circular wait that request resources should be in increasing order. Here 3 is already accessed by the P2. P2 cannot request 1 because it will be a false condition for the circular wait. Now you have understood how the deadlock will be occurred and how we need to prevent the deadlock. Then we'll go to the various handling methods of the deadlock. There are also 4 conditions of the various methods to hold a deadlock. First one, deadlock ignorance, deadlock prevention, deadlock avoidance, deadlock detention and recovery. First one, deadlock ignorance. It means that we just need to ignore the deadlock. Let me give a daily life example. When we use laptop or computer, when it's shut down or when it is holding for a halt for some time, then what we'll do? We just ignore the problem and we'll restart. In the same way, we need to ignore the deadlock. That is deadlock ignorance. Next, deadlock prevention. Prevention is better than cure. The same way, try to find solution before the deadlock. How will find the solution to the deadlock prevention then? I explained you before the necessary conditions of a deadlock. There we are preventing, there we are taking some measures in order to prevent the deadlock. Here it will be useful. Deadlock preventions. Next, deadlock avoidance. It means that when we are giving for one process, we are giving many resources. Then when we are giving many resources to a process, then we'll check whether it is safe or unsafe. Safe, leave it. Unsafe, then we need to avoid it. That is nothing but deadlock avoidance. Last but not the least, deadlock detention and recovery. We try to detect first. We need to detect the problem first. Then we will recover it. And how we will detect? How will recover? How will recover after detecting it? See, let me explain you. Kill the process or preemption. Preemption already explained you, like disconnecting. R1 is accessed by P1. P1 requesting to R2. Here I am preempting P1 to the R1. Then P2 will use the resources R1. This is preemption. So by using this, we can prevent detection, deadlock detention and recovery. That is the solution for the recovery. Thank you. Jai Hind.